Hello and welcome to Power Builder TV. In this webinar, we will look at a SaaS system written in PB Appeon. Today's presenter, Gian Luca De Bonis, has been a software engineer for more than 20 years. He has worked as a developer, consultant, trainer, and mentor, and led several international projects. He is the creator of Enable for Power Builder, PB Protect, Customization Studio, and other solutions for PB, and is currently Director and CTO of Enable Development. Welcome, Gian Luca.
Hello, everybody. In today's presentation, I'm going to show you something new, an SaaS system written in Power Builder with the help of Appion, of course, and it's a system that we have created over the past 4 years, and has been a huge effort, and gives some innovative results. And I'm going to show you the architecture of the system and to discuss the most important challenge that we have met during this development. In this presentation, I will talk about smiletron, what is smiletron, the functional highlights. I will run the system from the browser. I will talk about data calculation, that is the technology core of the system. We'll show you the system architecture, explaining how we have structured this, and talk about the most important challenge that we have met during this project. I need to tell you that the system is live and contains medical data that are reserved and protected by European laws. So I'm not allowed to show you sensitive data, and we are also using a test server with it's a test server but with real patient data. So I can't show you parts that are sensitive, and I will use a demo organization for just a few authorized patients. And I can't, I'm sorry, but I can't answer a sensitive question about the business because they are not disclosed. So what is smiletron? It's a medical system for cosmetic dentistry that allows dentists to design patients' smile. It's based on an international patent, and it's streamlining the collaboration between dentists and dental labs. It's innovative, and it's involving patients in the final results. I will show you in the session what I mean for this. It's a multilingual Power Builder Appion SaaS, as I say, and it's a CE medical device. European Union requires for any medical device that is validated according to CE rules. It's a class 1 device, so has been validated following these procedures. What the system does, basically, it's the macro functionalities are quite limited, but the system has tons of tools for allowing dentists and dental labs to interact. But basically, the most important functions are picture loading, calibration, and referencing. So that means we start by loading into the system patient pictures, calibrating them, and referencing point landmarks on the patient's face and teeth. The second important functionality is to execute a patient test and what we call the smile analysis, where the system calculates the proper size for each tooth. And then the collaboration part that allows dentists to send a service request to an authorized dental lab for actually creating prostheses, and for asking photo elaboration service that produces a simulation of the final result that will be shown to patients. Smiletron includes a social network of dentists and dental labs. They collaborate, they can share patient data with authorization according to European rules. I will run now the session, and I will show you the application running from a browser. I will run the system in Italian because it's the part that has been validated. the system it's multilingual, has been created in English, and we run in Italian for this session. I will show you the patient list. This is the main window of the program. Then we start working on a patient and show you what the users can do. That's not important to show you how the system works, but what I want to highlight is what is the final result that is available with a Power Builder and Appion system. So it will not be a session to show you how nice is the system from a functional point of view. I want to highlight the most important part. So when you are creating a system like this, can you really use Power Builder Appion, or this is not the best tool for creating this kind of system? This is the main question. Okay, let me go to my virtual machine. Okay, I have a Windows 7 machine. Let me open Internet Explorer 10, and I'm going to run the system. So this is the launch page of our system. As I say, we are running in Italian. The system is completely multilingual, so we accept also command line from the main website. We have a system for configuring the Appion add-ons, so that basically our users just need to press the button and connect to the system. The system updates everything, installs everything needed, so basically installation is trouble-free. We are running, as I say, in Italian, but we can switch language on the fly. And that's the system running. So you can see that the user interface is a bit different from a standard Power Builder application. Well, that was the goal. Let me show you a bit different interface on the MDA frame. I'm opening the main application window, where you can see basically the patient list. I'm just highlighting the most important parts of the interface. So basically here we have a patient, we have some features, we have the subscription balance and expiry, we can top up the account, extend the account, and see all the transactions. Basically what I will do now is to open a patient. That dialog that you saw, it was a synchronization dialog. I will talk about this later on. And basically we are now seeing patient data, and I can switch to patient pictures. So we have this navigator that opens this area. You see that we have this help desk bar on the left that is always active. That allows us, without leaving the application, to connect to our support website that has a live chat feature and has knowledge base, news, and everything else. This support website is multilingual as well. So what we have here, we have one list of pictures. Okay. Did anybody tell you that browsing picture in an internet application is very slow? Well, we needed to solve this problem, of course, because patients' pictures are large, and we need a way to speed up the application. But as you can see, the application runs very quickly. I mean, in a way that is difficult to find in a web application. We have this component that we use with all usual drag and panning techniques. Okay. And so we have several pictures of the patient. So as I was saying, we have one of the functionalities is to load patient pictures, to create them, so to give to each picture the correct reference. So for example, this picture. Okay. So we have calibrated the picture. We know that this distance is exactly 59 millimeters. And we will use this for referencing every distance in the patient picture. We go now by using this navigator. You see this is also a kind of control that usually we don't see in Power Builder application, but we have created something that is web-like, nice to see, easy to use, and very well integrated in this solution. You see that we have no menu bar, we have no status bar. That was a requirement for the user interface. So basically, this application, this part of the application shows parameters that we are going to test. For each parameter, the system shows the proper picture where to take this measurement, and basically the measurements are automatically performed by using a script language. And for each picture, we see the proper picture, some additional pictures. We can see the result. We can see some diagnosis, treatments. We can have attachments that show how this picture, how this parameter is meant to be measured. Okay, we can leave this open and show you now how we can quickly change and scroll through parameters. And basically, considering all the activity that is done, the system is synchronizing pictures, it's synchronizing parameter, updating updates, attachments, and all the related parameters. You can see how quick is the application. And when I double click on a picture, I have some points, reference points, landmarks. It shows me how to take a point, the guideline, and so on. I can also execute a calculation that will be performed on a virtual machine, on a web service, that I will explain later on, that basically will calculate this parameter by using geometrical algorithms. Okay. Web service have this technique of compiling and caching, so first time the web service requires more time for being executed, and all subsequent calls are basically immediate. Okay. So the system is calculating the angle between these 3 points, and in case we need, we can also measure some points as needed. Okay. We can take this measurement, for example, from here to here. And this is basically what we perform normally in a Power Builder application. Just that we are not in Power Builder, we are in a browser. We would say with limited functionalities, but actually you can see that we have all same features and the application runs very, very good. Okay, we have also, when we perform a test for taking, basically we take all landmarks on the patient pictures, the system will guide us to take the needed points to satisfy the system, and then we go to a smile analysis. That is basically the result, final result. The system says, based on a very complex algorithm that executes about 20,000 steps, it says that these are the ideal measures for this data set. And we can have a list of original measures and variations. So, based on all the system knowledge, this is the final result. But the system is innovative because starting from pictures and from landmarks, that is redesigning the patient smile by answering the question and by positioning accurately these points. When all measures have been fixed by the system, dentists can also change some, they have some customized settings. But basically, the system says that this is the ideal smile. So when building or changing these teeth, this is what we need to change. And just to show you on this patient what we have done, we started from the original picture, number 1, and we obtained this one. So we started from this, and we obtained this. This graphic simulation is not automatic. It's done by graphic artists that simply apply the final result calculated by the system. So graphic artists will follow exactly the rules. But why is important? Because the dentist is not changing the teeth set according to creativity, inspiration, and art. It's following measures that have been determined by the system. When the patient sees the final result, can decide to accept this, undergo this procedure, this operation, or maybe not. And the cost in this sense is referenced with, is attached with results. So this patient that has a beautiful smile, actually, when we calculated all the change, you can see that, I'll show you here, that teeth change slightly because her teeth are almost perfect, but still there is space for improvement. There's no space here, for example, and here there is some change. So this is the way that the system works. Let's go back to the presentation, and so that I can show you, technically speaking, why it was so difficult. The technology core of the system is the teeth calculation. It's a complex intelligent algorithm based on a network with feedbacks, based on test results and medical decisions. So the system starts from pictures, from landmarks, from medical questions like structure of skull that dentists know how to answer. And based on these results, the system runs an algorithm that has feedback. So iterates several times until the results converge to a final stable result. And typically 20,000 steps are required, depending, of course, on patients, on landmarks, etc. And this web service, that is the where we spend all this time, executes these 20,000 steps in about 30, 60 seconds, depending on the patient. So the system includes a virtual machine and like a command processor, like a power builder virtual machine, in a script that we call a smiletron script, and it's a proprietary script language. So inside the system there is a command processor that is able to execute geometrical calculation algorithms and calculations on landmarks, and is able to make all these calculations. I will show you some more details on this. Let's talk about system architecture. We have the usual client connecting to the server. We have an IIS server as front end that will direct traffic to an array of Appian servers. These Appian servers rely on a cluster of database servers. The Appian server of course, can handle thousands of connections, but here is where we found problem for scalability. Appian server scales up very, very good, but we need to calculate our super heavy web service. And for this, the Appian server calls the proper web server with a load balancing algorithm, so that basically the web server executes on the best machine using all CPU power and connecting, of course, to database for doing all retrieval, and also connects to a non-structured space. Basically, in our application, we don't have just database data, we have also multilingual data, but we also have non-structured space, like attachments, images, etc. These are not stored in database because of technical architecture, because of the size of these attachments. Basically, we have 20 terabyte space for this non-structured space, that we need to address in a smart, special way, and I will talk about this a bit later on. I want to show you how the algorithms look like. So basically, this is just an example of our programming language. We highlight points, we draw lines, we calculate vertical line, best approximating vertical lines. We have check parallelism between lines. We have all basically geometrical algorithms. But these are used then for calculating the real size of a tooth, considering all the parameters results and medical decisions. So basically, if I show you how a parameter executes, let me go to a parameter that is a bit complex. Okay, let's go to A131, A133/2/1B. So with this parameter, the system understands what is the size, what is the shape of the arc, data arc. So based on this, the system executes an algorithm. And I'll show you the script later on. So basically, based on these landmarks, the system designs the shape and it says, that's oval. How he knows? He knows because based on these points, the system, I'm going to open now the administrative part of this application that is not visible to users. Okay. This one to run. Okay, just a moment. Today doesn't like. Okay, we have another solution. A133/1B. Okay, A133/ yes. So basically, in our algorithms, we are going to 133/ okay. Well, the one that I wanted is not available. I don't know why. Okay, well, that's good enough. So basically, we highlight some points, we draw lines between them, we calculate this angles between lines, we calculate what we need to, we make some comparison with documented let's say the scientific reference where people were studying and proving these results. So we are using in our patent all certain results. And the system determines that for this, the proper shape is oval. And I have another algorithm that calculates two B-spline between points, giving a simulation of the current arc and the ideal one. So the system actually uses this algorithm, this processing power to determine all the proper results. As you can see, all data are output in Italian, but the system contains data, multilingual data. So we translate on the fly, not only user interface, but also database data. And this is handled by Enable that is running on Appion. We are using on this server Appion 6.6. We plan to add the iPad support. And okay, I want to show you now something more on the presentation about our challenges. So, what was so difficult? What was difficult to be created? We user interface, as you have seen, it's created for the browser. I mean, it's this application has not been converted from Power Builder to Appion, has been written directly for Appion. And it features a multilingual user interface and has some special aspect without MDI sheets, without menus, without status bar, and that was a specific choice to make the interface simple and let's say more natural for the browser. Also was difficult to select the proper ActiveX for image drawing, zooming, and panning. You see that result, it's the same that you can have in a client application, client-server application. Of course, you need to install some component, but what we have done, we have created a button that I've shown you in the startup screen. This button basically checks if everything is installed or not. If not, downloads one-step program that silently installs everything and gives the user a report like everything is installed, website is marked as secure, as trusted. This setup is of course signed, so it's authorized. And when the step program completes the execution, we have the system ready for use. So of course it's not same as an application for casual users, but in our case it's SaaS, so it's software for authorized users, for professional users only. That's why the browser restriction that will be removed by Appion next year is not limitations for us. So we run Internet Explorer. In the future we can run on other browsers, but basically for us the browser choice is not an issue. Another important challenge was about image synchronization and non-structured space. So image synchronization in web application, uploading and downloading image, it's time consuming, it requires large bandwidth, and it shows at the end image very slowly. So what we have done, we have implemented a synchronization technology for which the images are cached on the client side, and every time we connect to a special patient or a special organization, we merge, we check image by running MD5 signature check. So we don't need to download image, we perform server-side or client-side comparison by comparing just the hash of image, and basically we download what is needed. That means when we run the system on another computer, we don't need to synchronize anything. The system just doesn't find what it needs to find and synchronize everything, downloads only the image. You can see that when we run the system, when we open image, I'm running from a professional connection, but nothing extreme. Images are synchronized immediately. The other challenge was about non-structured space. So imagine you have you store your attachments, your image, not on database, but on cloud space. So how you, that's necessary because the space for non-structured space is less expensive than database space. So imagine that you have, like in our case, 20 terabytes of data to carry on. Of course, you can save this data in the file system, but how you make backup of 20 terabytes? So we have the problem of data backup, synchronization, and redundancy. You can have every redundancy system with RAID and everything you need, but this is not enough. Every hardware can fail, and other than implementing redundancy at Appion web server and database level, we needed also to have a real-time copy of this data. So what we have invented, when our client is uploading an image, the one web service will be responsible for this, will upload image and save in multiple locations, all in a synchronous way, so that basically we have a real-time backup of attachments. The other challenge was implementing credit card processing. So you may guess how it's possible from Appion to connect to a credit card system, because basically it seems like the system is closed. But actually, Appion allows you to do this in an elegant way. I will show you. Then we have the virtual machine, that it's a real, like the Java virtual machine or the Power Builder virtual machine. It's a command processor that interprets in real time the scripts, execute them on a web server, and returns results. So you have seen that these commands have an output effect. So how is it possible to execute on a web server something graphic? So the architecture allows to execute calculation and pipe command results that will be forwarded to the client, that will redraw part of this command that makes sense to that requires some output. So with Appion you can basically implement this kind of communication. You can implement Power Builder web services. You can deploy them and use in a very easy way, and then performance are extreme. The system runs very, very quickly even on calculation. Consider that for the 20,000 steps that are used for performing calculation, we also keep a full trace of every patient, every test, every organization that is running on our system. And this without basically a very long process that would have been necessary when running the application in Power Builder and deployed with Appion. So to give you an example, the web service, the virtual machine, was executing for the same patient in about 20 minutes. And after this optimization, rewriting, and of course transformation in web service, the complete calculation runs between 30 and 60 seconds. So it was a huge improvement because the web service is optimized. It's runs on server with dedicated resources, and basically the client just waits that the web service finish computation. The other challenge was about scalability and redundancy, because of course you need to take care that any of these components keeps running. You can have a problem on the web servers, you can have a cluster of them, you can have a problem on the Appion server, but basically if you have all services on a single server, you have a scalability problem, because you can't scale number of web services, you can't scale number of database servers, considering one server for all functionalities. Instead, we have scaled up the system by dividing proper components and by activating multiple instances as needed. So, for example, web services have 4 CPUs, octa-core machines that can run thousands of calculations seamlessly. And the database servers have a live backup technique, so they are backed up in real time. So structuring the system architecture was not a trivial task, and required, of course, some special coding technique for writing the load balancer for web services. So basically our Appion client will execute the web service on the proper server, proper web service, depending on the system load. And let's go back to credit card processing. There is one of the part of the system that is I believe more interesting. Let me see if we need to, yes, let's go to patient list. Okay, so I have a balance of 0 credit, and what I want to do, I want to top up my account. So how to do? I select my the button here on the bar. I have a list of available services just as a reminder to understand how much I need to top up. Maybe I want to charge 500 credits. And these 500 credits will have a price. So I will we use the PayPal link. We can also support money transfer and other ways. And when I confirm it, the system will open a PayPal page for the payment. And you see that the system will be still running. I will show you later on, and can check for automatic transaction. So basically, I'm waiting that I will input all my credit card data, and upon confirmation, the system will update the transaction state and will execute the transaction, topping up my account. Sorry for this presentation, I will not pay this 500 euros, okay? But basically this is how the system works. When we confirm it, we have the system waiting for the payment. And when the payment will be received, the transaction will be executed. And all operations that are listed here, you see this running. It's waiting for the transaction from payment. It will be executed and will top up the account. To write the PayPal interface or any other credit card processor, we needed to find specification and from the gateway. And basically, what Appion gives you the possibility when you prepare this screen is, let me choose something that I can easily cancel. Okay, let's do it again like this. So basically, when we press confirm, we are using a static hyperlink that will receive the command for going to the PayPal page by passing all parameters that the gateway requires. So it's really as easy as it seems. You just prepare a proper link. You will be directed there, but the application will not close. So basically, the application can continue to wait for transaction, or with a timer, or with a continuous check, with a cycle. We also have idle detection. So if you leave the application idle for 10, 15, 20 minutes, I think our 10 minutes is about 1 hour, the application closes itself, saving data and giving a message like everything is saved, the application is closed, and without issuing any exception like data not saved. That is typical in a browser application, unfortunately. We decided not to remove the Appion, the browser page, the browser title bar. So of course the user can press back or can press refresh, but nothing happens. We just reopen the start page. Every data is saved by default whenever you navigate out. So basically, you just need to log in again and you can continue using. We also have multi-user lock and things that you can that you usually perform in a client-server application can be performed as well in a SaaS. Basically, we just manage permission, user rights. We have created a part of the system for this. We use Visual Guard for server-side authentication, but for client-side we don't use anything else in our routines. That's it. These are the most important features of the system. I wanted to give you an overview of a complex system created in 4 years of development, showing you what is possible to achieve with this toolset. So basically what we used, our beloved Power Builder, Appion 6.5, 6.6 enable visual guard and some components that we needed to use for image visualization. And basically tools that you have that you currently use allow you to create complex system leveraging web services, using links, using command line processing parameters. I'll show you that, for example, if I go directly to the server address, let me see if it's like this. We start in English. So you can write a system that it's run from, it's launched from an institutional website, passing parameters as you need. You can implement a single sign-on the application side, and your basically institutional website will just redirect you to the application passing proper parameters. Of course, authentication is better to be run here because that's the application is secured.